HCF Maths. In this video we're going to look at how to calculate or work out the highest common factor of two terms and the lowest common multiple. We're also going to have a look at writing in index notation, expressing a number as a product of its prime factors. First thing we're going to look at is express 2400 as a product of its prime factors using index notation. What you need to do when you're expressing it as a product of its prime factors is you sort of like need to break the number down using a factor tree. So what we're going to do is we're going to write 2400 at the top of the page, and we're going to break it down. Now we need to think about what two numbers we can multiply together to make 2400. When it ends in a zero, I generally break it down into tens by tens, so we've got 10 and 240. And what you need to do is you need to keep on breaking it down until you've broken it down into prime numbers. 10 can be broken down into 2. That's a prime number, so I'm going to circle it. And 5, which is also a prime number, so I'll circle that. I've got another 0 on the end, so I can break it down by 10 again. And 24. The reason I like to break it down by 10 is it breaks the number down quite quickly. It makes the numbers easy to deal with. And now I've got 2 and 5 again, so I'll circle them. And 24 I can break down into 6 and 4. 4 I can break down into 2 and 2. And 6 I can break down into 3 and 2. So now I've got the factor tree, and my question asked me to express it as a product of its prime factors. And what that means is if I times all those prime numbers together, I would get 2400. But I also need to use index notation. So what I'm going to do is I'm going to just count up how many 2's I'm going to need to calculate, add together. So in terms of 2's, I'll have 1, 2, 3, 4, 5. I've got 5 2's, I've got 1 3, and I've got 2 5's. So my answer would be 2. And because it's in index notation, I need to use powers rather than doing 2 times 2 times 2 times 2 times 2. I do 2 to the power of 5 multiplied by 3. I've only got a single 3, so the power's just 1, which you don't include. And I've got times by 5, and because I need to multiply by 5 twice, I do times 5 squared. And you could even check that on your calculator if you wanted to. If you multiply those together, you will get 2400. Right, for question 2, so we need to express 330 as a product of its prime factors. Like we did last time, I'm going to have 330. I'm going to break it down into 10 and 33. That'll give me a 2 and a 5. And 33 breaks down into 11 and 3, which are both prime numbers. So if I wanted to express 330 as a product of its prime factors, I'd do 2 multiplied by 3 multiplied by 5 multiplied by 11. Now let's get on to our highest common factors and lowest common multiples. And I'm going to use something called a Venn diagram for this method. I don't know which method you used at school, but we need to find the highest common factor for 132 and 330. Now what the highest common factor means, a factor is something that a multiple of that number. So for example, 4 would be a factor of 8 because 4 times 2 is 8. So we need to find the highest factor which for both 132 and 330, which occurs in both of those. And for this method, we can actually use our product of prime factors, which is why we've done a couple of questions on that so far. We'll need to also express 132 as a product of its prime factors. So if I have 132, I can first divide it by 2. So I'll split it into 2 and 66. And 66 breaks down into 11 and 6. And 6 breaks down into 3 and 2. And I'm going to draw a Venn diagram. So I'll give it a decent overlap. And I'll have 132 and 330. Now what I need to do is I need to put the numbers in the middle which occur in both. So if I look at what occurs in both, well, 2 occurs in both once. So I'll put that 2 in the middle. 3 occurs in both once, so I'll also put that in the middle. And I'm just crossing them off so I know which one, so I don't get lost there. And 11 occurs in both. What I can see is in 132 there's an extra 2 there. So I'll put the 2 in there. And there's an extra 5 in the 330, so I'll put an extra 5 there. So that's what just appears in the 332 and what just appears in 330. Now if I want to calculate the highest common factor, what I do is I multiply the numbers in the middle of the equation, which includes the numbers that occur in both. That will give me the highest common factor, because if you use the prime numbers to multiply to get that number, any numbers on the way must be a factor. So what I need to multiply is 2 times 3 times 11, which will give me 66. So 66 is the highest common factor of 132 and 330. Right, so question 3, express 104 as a product of its prime factors. And this one's a little bit more tricky, it doesn't end in a 0. I'll divide by 2 because it's even. That will give me 52 and 2. And then 52 I can divide by 2 again, which will break down into 26. And then 26 I can divide by 2 again actually, and it'll break down into 2 and 13. And 13 is also a prime factor. So 104 is a product of its prime factors. It will be 2 cubed times 13. I'm going to try and compare it with 65. I'm going to find the lowest common multiple between 104 and 65. So if I get my 65 here and break it down, I'll divide it by 5, and that'll be 5 and 13, and actually those are both factors. So my product of prime factors for 65 is just 5 times 13. And let's draw our diagrams. So we've got that and that. So we'll have 104 and 65. And if we look at what appears in both, well, the 13 does. So if I cross that out in both of them, and I think that's the only thing that appears in both, so I'll put 13 in the middle. I've got two number 2s in 104, so I'll have 1, 2, 3, and I've got a number 5 in 65. Now, the highest common factor for that will be 13, because that's the only number in the middle, but we're trying to work out the lowest common multiple. And when you try to work out the lowest common multiple, what you need to do is you need to multiply by all the numbers throughout the equation. So what we'd do is we'd do 2 times 2, or I could just write 2 cubed, times 5 times 13. And if I times those numbers together, what I get is 520. Therefore, 520 is the lowest common multiple of 104 and 65. So what you need to remember is that when you're calculating the highest common factor, you just use the numbers in the middle. So, and when you're trying to calculate your lowest common multiple, you need to use the numbers in the whole equation. So you're multiplying by all of it for lowest common multiple, and just the middle when you're calculating the highest common factor. And just an example of how a question could be worded. An electronic device has a green and blue light, and you've got the green light flashes every 10 seconds, the blue light flashes from 16 seconds. And you're going to work out that if they both start by flashing at the same time, how long it's going to take in seconds before they both flash again. So what I'm doing is I'm basically working out the lowest common multiple, because I want to find out the next time that they're going to flash at the same time. And if I was to work out, so 16 is breaks down into, well, it's going to be 2 to the power 4, I know that, because 16 breaks down into 4 and 4, and that'll be 2, 2, 2 and 2. So 16 is like 2 to the power of 4, and 10 breaks down into 5 and 2. Therefore, if I do the Venn diagram, 16 and 10, a 2 occurs in the middle. And then for 16, I've got 1, 2, 3, because I've got 3 extra 2s. And for the 10, I've got an extra 5. And if I want to calculate the lowest common multiple, as I said before, you need to calculate by everything. Therefore, I'm going to do 2 to the power of 4 times by 5, which is basically 16 times 5, which is 80 seconds. So if they both flashed at the same time, it'd take 80 seconds before they both flashed at the same time again. So we calculated that by calculating the lowest common multiple. Right, thank you for watching. I hope you found it helpful. If you liked the video and like to see more, please hit the subscribe button. And for practice questions, please visit www.mitchellmathsandscience.com. The link is in the description.